All right, guys, we're on the back side of day 8 notes, and in number 3, it says, in the diagram to the right, triangle DEF is the image of triangle ABC after 2 transformations. Describe the transformations that were or where it was performed. Okay, so let's take a look at where our original triangle is. So we know what we're starting with. And then it looks like it maybe went to this triangle. Okay. And after it became that triangle, then it became that triangle. All right. So here we go. In number 1, oops, we're going to go ahead and say that triangle ABC, okay, went to triangle A prime B prime F. Okay. It looks like I would have to rotate it around, right? So we'll say a rotation around, and it looks like here P is our center of rotation. So around P of, and that's 180 degrees you had to turn it. Okay, so that's good for the first one. In our second transformation, then we became this triangle called DEF. And notice it's bigger, so automatically that's a dilation. Centered at, looks like F. Centered at F with scale factor of, and now we got to figure out our scale factor. So remember, easiest way is if we can count or figure out the length of our sides. And so we can, because this side here is 2 units, and this side here is 3 units. And so we remember that it's new divided by old. Our new side is 3, our old side was 2, and that is our scale factor, 3 over 2 or 1.5 as a decimal, doesn't matter. All right, and so that's how we could write it, or we could also do our notation with our composition and our open circle. Okay, remember that the first one that we talked about was the rotation, so that would go second, so that would rotation around P of 180 degrees. And this would be our dilation, centered at F with a scale factor of 1.5. All right, so that is just one way we could go ahead and write it. Okay. All right, so then part B asks us to explain why the triangles are similar. Okay. And so we will. And so we'll go ahead and say that rotations and dilations both preserve angle measure. So all corresponding angles are congruent and triangles are similar by angle similarity. All right, so same thing that we wrote on the other side. In fact, all of our transformations preserve angle measurements, and so we can kind of use that to realize that the sentences we just wrote would be the same no matter what transformations we had. All right, let's try number 4. Given the coordinate plane shown, identify a similarity transformation if one exists, mapping x onto y. If one does not exist, explain why. So we want to go from x to y. So x is our original shape that we start with. Looks like a parallelogram. And it's going to go onto y. So I think the first thing I notice is that there seems to be needing maybe a reflection, a flip over this line here. Okay, and that's a vertical line. So think VUX, think x equals a number, and this would be x equals 11. So I'm going to go ahead and say that there's a reflection over x equals 11 is the line of reflection. And in order to see things a little bit better, I'm going to go ahead and graph what it would look like once it's reflected. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Graph's a little light. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, so I'm just going to sketch it in what it would look like if I did reflect X over that line. And so it would look like that. And so now I think all you can see is that it needs to be shrunken down. And so changing size is a dilation. Centered at, and I think you can see that the center would be this point here, which is 11, 1. Okay, with a scale factor of, and now we got to figure out what our scale factor is. This one's going to be a little bit tricky just because there are no sides that are horizontal or vertical where you can count, but I think you can see right here that this side, when I've reflected it over, and this side, you see how that's half of it, right? And so I believe your scale factor is going to go ahead and be a half because it shrunk, okay? And so we could go ahead and write that as a composition if we want again. Open circle means following. And remember that this is the first one. And so that was our reflection, which is a lowercase r. And our subscript would be x equals 11. And then here would be our dilation. It's centered at 11, 1. So you would have to write that into the subscript, which is a little bit tricky. And then a comma, our scale factor. All right, but that's what the notation would look like. All right, we got one more. And in number 5, it says a similarity transformation maps triangle ABC onto its image A prime, B prime, C prime, and it wants us to define the transformations. So our first triangle that we have is this one. And it is going on to the smaller one. So I think automatically you can see that it's going to shrink. So maybe we can shrink it first. And so if we shrink it first, all right, that would be a dilation. Okay. We can come up with centered at. And I think you guys can see that it would be centered at C. That point staying the same. Okay, with a scale factor of, and remember, new side of 5 divided by old side of 10 reduces to a half. Okay. And so if we go ahead and we shrink this all down to a half, so if I take AC side and half of it would be here, okay, half of BC side would be here, and if I connect my 3 points there, that's going to be what my triangle would look like after I shrunk it down. And now I think you guys can see that all we have to do is flip it. Okay, so in number 2, that would be a reflection. And we would reflect over CA or AC, doesn't matter, or CA prime, doesn't matter, whatever you want to call this line. But that would be the line of reflection. You could take any 2 letters on it. All right. And so if we wanted to write this as a composition, okay, our first dilation would go in the second spot. And so we would say a dilation centered at C, scale factor of a half. And then we did a reflection over CA or AC, doesn't matter. All right. And then, so that's how you figure out what transformations you are doing to make the figures similar. All right. I will see you guys on the next day.